Okay, welcome everyone. This is the panel on the tools and techniques for Java to Kotlin migrations. So we've got some amazing panelists up here today. I'm James Ward, a developer advocate at AWS, and we've got some people who are going to introduce themselves in a minute. But just a little bit of background. I was at Google a little bit ago, and so we started this work group of people across Uber, Google, Meta, and JetBrains to try to figure out, can we collaborate on tooling and processes and knowledge sharing to make the process of migrating from Java to Kotlin easier? So these are representatives from that work group, and so they're going to be, answering all of mine and your questions. We should have time for questions at the end. But these people represent teams of people who work on these tools. So even though they get to be the lucky ones to be up here, there are many other people that are part of this work group and part of these efforts at these companies. Okay, so let's first just start with a little bit of, for these companies, these people represent some companies that are doing a lot with Kotlin, and we thought it would be good to start with just why Kotlin? I think for all of them, there's a lot of Java in their history, and so we thought just to level set, why in the world would we even want to do this Java to Kotlin thing? So let's start with Ty. So Ty, you're Uber. Tell us about yourself and tell us about your journey with for why Kotlin.
Sure. I'm Ty Smith. Do you want to go to the next slide while we do
Oh,
that?
yeah.
Yeah.
Great idea. Thank you.
So why Kotlin? I've been at Uber 8 years, and I've pretty much seen the entirety of our Kotlin story from the beginning till now. I think at the beginning, we were coming hot off of a Swift migration from Objective-C for our apps and a full rewrite that had scared a lot of leadership. So when we started the idea of thinking about Kotlin, it was a little bit scary for the organization. But we were looking at a large Java code base for our Android repo and seeing a lot of challenges there. It was a legacy language. Android was stuck on something much older. We were starting to have the need for a modern language, for something more concise, modern language features, and didn't really see an opportunity for that with Java on Android. And so we started with some early prototyping and build out shortly before Google made it an official language for Android. And once they did, we invested pretty heavily. We wanted something that was future-proofed for hiring, future-proofed for new investments coming out, and then would capture a lot of the investments, or a lot of the wins that were kind of publicly known at the time. And once we started with our migration and we got really into it, at this point we're about 50-50 Kotlin to Java in a 10+ million line Android repo with no new Java allowed, and we're thinking about how to get the last of it across, which we're going to be talking about today. But we've seen a lot of really nice benefits that came after the fact. We saw the developers who were working only in Kotlin had a much higher throughput than the developers that were still working on legacy parts of the code base. We saw an average much lower amount of cyclomatic complexity for our Kotlin code compared to our Java code when we did an analysis there. Our code was 30% smaller, reviews and files, than our Java code. Review time for engineers was lower. So we started to see a lot of benefits that weren't immediately obvious, or at least we didn't have the metrics on, that we've been really happy about in retrospect.
That's good to hear. I think everyone here loves Kotlin and loves to hear good things about it. So Kevin, tell us about yourself, and at Google, what's the journey to Kotlin for you?
Yeah, so I lead the team that supports Kotlin internally for Google's own use, and in some ways this is self-evident. We wanted to use Kotlin, the language that Google wanted to support externally for Android development. We wanted to have that be used internally as well. But that's how we started. But it turns out people really like it. So we've been working on this for quite a while, and eventually extended support also to the development for the JVM, and now have people using it on both platforms. And then additionally, we got interested in Kotlin multi-platform, in particular for the workspace apps, and that's really where we got into conversions. That we're going to talk about today.
Awesome. Thanks, Kevin. Okay, Eve, you did a great job in the keynote this morning. So tell us about yourself and Meta's journey to Kotlin.
Hello. So as you probably heard earlier today, we've got about 20 million lines of Kotlin right now in our Android repos, or repo, I should say. And this started in like 2019, so that predates my involvement. It was actually one of my teammates, Omer Strulovich, who kind of got this ball rolling, and then other folks who joined in to make all the tooling work. And it has kind of snowballed from there because people love it so much. It's been kind of an easy sell. Usually once they use it for a couple of weeks, they're pretty sold. We've had exactly one request, to my knowledge, to translate anything from Kotlin back to Java. And I think that person was like lightly tarred and feathered. So it was already pretty popular at that point. So yeah, at this point, more than half of our Android codebase is in Kotlin. We'd like to take it even further than that. Almost half, at least 7 million lines of that is code that we have converted from Java. And we're still going.
Awesome. Great. All right, Anton, you're at JetBrains, and tell us about yourself, and then you want to tell us like what you've heard from customers about Kotlin, right?
Right. Hi, everyone. I'm Anton. I'm product manager in Kotlin, and I investigate experience of our users, of Kotlin developers. And a couple of years ago, we conducted a survey where we asked developers who recently migrated to Kotlin, tried Kotlin. By recently, I mean like half a year to 1 year approximately. And we asked them how that experience was, what did they like, how Kotlin was spread inside organizations. And as a result, we got a kind of aggregated picture of how they persuaded their teammates, other teams, other projects to try Kotlin. James, could you please switch on to slide, why Kotlin? No worries, I will not list everything here. I just, so it will be available on recording. I just want to highlight 3 segments here. First one to the right is language features, second one ecosystem, and the third is developer productivity and developer satisfaction. And what I really like in big companies is that usually they have special teams who work on improving internal development experience, and they have numbers, they have metrics, and it goes easier to having that numbers persuade other teams to try Kotlin as well. The numbers are different. Usually they are positive, but very different because very different things are measured. But I can share my finding from that survey as well, is that when we take a look on any single feature, it actually barely contributes to development productivity. But higher level things like combinations of features, libraries, frameworks, they really do. And why I'm talking about it, because we often hear that like this language has sealed classes, that language has implicit receivers, Java got powerful pattern matching, but
It has records. It has everything you need.
you still cannot write compose with Java. DSL capabilities, compiler APIs, multi-platform, so a lot of things. And only cohesive experience really moves productivity forward. So that's what we see.
Awesome. Well, that kind of leads into the next topic that I want to cover, which is for, I think, some of the people up here, they've gone on this journey of Java to Kotlin, but now you live in this painful world that is not Cody riding a unicorn. It is actually kind of challenging to be in a mixed code base world. And so, Ty, tell us at Uber about the challenges to being in a mixed code base.
Sure. I think it's worth breaking this into 2 parts. One is just the challenges of Kotlin in a very large repo, and then kind of it goes very cleanly into the special challenges that happen in a mixed code base. So when we started trying to adopt Kotlin, we were on a buck-built system. We had outscaled Gradle. We're now in the middle of moving to Bazel. Both of those have non-first class Kotlin support. So we found ourselves building a lot of the tooling, really immature tooling at the time. That's everything from integration directly in the build to missing static analysis tools or less mature static analysis tools, and all kinds of other integrations that might be missing. So one piece of it was that. Another piece was, Kotlin is just much slower to build than Java at the time. Even though we were using error-prone, it slows down Java C. We still, we published an analysis with JetBrains in 2019 on the build speed times on large repos, and it got up to 4 times as bad in certain use cases, and we had to put constraints in place, and that really slowed down our initial adoption. Especially with things like annotation processing. We did find workarounds eventually, but these sorts of things were big challenges. Then, once you get a lot migrated, you're dealing with this mixed code-based world, and the interop itself starts to bring challenges, and a lot of those are challenges to reliability and risk to the business. Uber's an app that puts a lot of emphasis on reliability because we're a utility people use to get to work or drive and put food on their table or go to the hospital. And so those challenges started to become real problems for us. Things like nullability. Even though we use nullaway, which is an error-prone JSpecify tool to try to enforce nullness in Java, you still get platform types or you get misidentified nullability when you get that into Kotlin, and those cause real runtime issues. Similarly, issues with generics or weirdness in immutable versus mutable classes as they go across the bridge. All of these can result in runtime issues that we had to be really cautious about and have helped motivate our migration to push more aggressively to get to Kotlin.
So some challenges there. And Kevin, anything specific to Google around challenges with the mixed code base?
Yeah, so I mean, we don't centrally drive conversion like my co-panelists here do, but we do have some Java-based tools that we use to cross-compile to Objective-C, and when we wanted to look at Kotlin multi-platform and use Kotlin native, that became a challenge because, well, you need Kotlin in order to get there. And so my colleagues on the workspace team who are here to keep me honest, they built a tool to kind of mass convert all of their Java code that they traditionally process with J2Objective-C to first convert it to Kotlin and then be able to run it through the Kotlin native compiler, sort of at a large scale, kind of as an intermediate product, right? So no one ever sees that code. It's sort of a write-only thing that then the build system uses to use the Kotlin native compiler.
Cool. Eve, anything to add on anything we missed, forgot to talk about?
It's a pain to maintain 2 sets of tools.
Yeah.
And static analysis is very hard.
So the ideal then, I think in a lot of these cases, is to get to 100% Kotlin. But with decades of Java code out there, it's a really hard problem. So that's what we're going to talk about next. So you want to migrate. You want to get all that Java code to Kotlin. But there's maybe some challenges there. So let's talk about how we are taking different approaches to overcome those challenges. So we'll start with Anton, talk about what JetBrains has there.
Yes, in early years, when we were developing Kotlin as beta Java with full Java interoperability, the creating code converter was quite a natural idea because it was a primary use case. Apart from creating application with Kotlin from scratch, you usually gradually add Kotlin to existing Java code. So converter was needed. And we made it. Our engineer, Ilya Kirillov, was working on it and was improving it later for like 2 years approximately, from time to time. And now we have it. And how does it work? It uses powerful IntelliJ code analysis to analyze Java code, to create a kind of more abstract representation of that code with additional information about it. And then, having that information, having that model, it gradually runs, iteratively runs different conversions, building Kotlin version of the code. By iterations, I mean that in one iteration it builds class declarations, in another one it's string literals, scopes, modifiers, annotations, comments, different things, but at the end you have workable Kotlin code. I'm saying workable because you need one more step to make it readable, right? You need some polishing, we call it post-processing, and it performs formatting, It changes calls to Java standard library by Kotlin analogies, yeah, and things like that. And finally, you got code that looks like written by a human.
Nice. Okay, Ty, let's go to you and talk about how Uber is approaching this problem of migrating that code.
Sure. I mentioned earlier we were kind of on a conservative adoption journey for a while, and so a lot of that was, taking developer feedback and thinking around tools to assist them. And I think we're in the middle place of our maturity here. And when we go to Eve here in a bit, talk about more of the advanced versions of this. But we're currently in this model of providing developer-assisted tooling to help out. We think JDK is a great start, but there's a lot more that could be needed for certain repos and certain patterns to really make the code that's generated or transformed automatically much more human readable, idiomatic, correct. And so we have a tool. Do you want to go next slide?
Yes.
That a couple of folks, a couple of my coworkers built. Anton, who's here, and Kieran, who's not here, worked on this tool called Rectify, which is essentially a wrapper on J2K. Actually, this banner that we have here was written by my other coworker, who's here, James. But we ban new Java right now, and we discourage any contributions to existing Java, and we try to motivate our engineers to move that over to Kotlin. So we have this call to action here, and if you go to the next slide. What this does is it wraps JDK. We try to handle the commit history automatically, do the rewriting that's needed. We'll change the build file. We'll run all these through JDK, and then we'll run a series of pre-processing steps before J2K to help out with things like nullable annotations. And then when it's done, a series of post-processing steps. When that's done, that's getting closer to what a human what it would look like. And then those teams own committing that and verifying and validating that. So a lot of teams will use feature flagging or A/B testing between the old version and the new version. Sometimes that's viable, sometimes it's not. It leaves a lot to be desired, and I think we'll think about maturing that more as the future goes on, but we can talk about that in a later question.
So I love that you disable new file Java in IntelliJ, but I kind of imagine that when they click that, it actually pops up the no soup for you, soup Nazi guy to just add a little more punch.
There's an idea. We should do it.
Yeah, let's do it. Yeah, no soup for you, no Java for you. Okay, Eve. Let's hear about how Meta does their migrations.
Alrighty, so like I said, about at least 7 million lines in. It's evolved into a bit of a beast at this point. The recurring theme, though, is we try and automate everything, partially because it's more efficient and partially because it tends to be more correct, honestly. So we actually try and do as much of this via bot on some remote machine as we can. So I'd say there are kind of 3 parts to the whole conversion ecosystem for us at this point. There are preemptive code mods that we run. A lot of them are focused on nullability. Actually, my coworker Jocelyn, who had to learn Java after she learned Kotlin and was horrified, is in charge of that. So that she doesn't have to, we're forcing her basically to deal with all the ugly Java now. So that kind of massages the Java into a better state, reduces some of the tech debt there. Then we have the actual conversion tool. We call it the Kotlinator. And the primary, it's kind of like flagship form, is as a code mod or a bot. So it is built around the JetBrains J2K converter, which actually we've had the chance to collaborate on with Ilya and Alexia JetBrains these past few months. And we do, like Ty said, also pre-processing, then the J2K converter, and then post-processing. And we actually cobbled together this headless version of J2K, me and Jingbo. And that has allowed us to basically just create conversion diffs, which are actually reasonably idiomatic, actually. If you could, yeah. So here is an actual conversion diff. It's not bad. It renames your properties. It'll do the backing property, update nullability, handle overrides properly. So this is some code that we converted in Fresco. This is like the internal view that I have, but you could actually see this conversion as a commit in the Fresco, open source repo on GitHub. These just pop up in developers' review queues. Then you accept it, ship it, and hope that it doesn't break anything. Generally does not at this point. Like a very, very small percentage does. And then we have all this automated tooling to make sure that if something does break, we know almost immediately. So I think if there are even just 2 people who experience a crash, it creates a task, it often gets automatically rolled back. We also, and this is surprisingly dumb but very effective, we just prevent people from shipping these conversions right before the branch cut, and that has saved me many a sub review.
Nice. So today I learned that Jocelyn is a Java masseuse. Sorry, Jocelyn, that doesn't sound fun, but somebody's got to do it. Kevin, so tell us about at Google, your approaches for these migrations. I know Google likes to do things differently than a lot of people, so tell us how you do it.
That's an understatement here. We certainly jumped in with both feet and kind of created a lot of our own tooling. Background to that is like we really have a lot of Java code, like a lot of Java code, and it's sort of all in scope for us, not just Android code, but JVM code as well. For KMP, we really needed a tool that can kind of convert a lot of Java code at scale automatically without anyone ever looking at it, and so correctness was really kind of paramount there. The workspace team worked very, very hard at creating a tool that can do this, that processes all the Java code that's in scope there. And this includes fun stuff like Guava that uses every Java feature in existence, including things like raw types that don't exist in Kotlin, that still have to be translated in a way that end up working and having the same behavior as before. So that tool is open source, it turns out, but in particular is sort of used in the build tool chain. And then we've also been working on a tool for manual conversions that we can run standalone. I think this came up here before, that J2K is very tied to IntelliJ, and we have a long history of wanting command line tools and things like that. So we've been working on a tool that we can run standalone and that we can also kind of scale to the level where we think we need it.
Awesome. Okay, but it turns out that we've got some great approaches and processes, but it still is kind of hard to do these migrations. And so let's start with Eve. Eve, what's hard about this?
Nullability is very hard. So actually, if you wouldn't mind showing the next one. Yeah, so this is code that I actually broke in July of 2022. This was a conversion generated by the bot. The bot did a very good job of creating it. I did a very bad job of reviewing it. I shipped it right before July 4th weekend. Then I went on vacation, and then I got COVID. And so that was not helped by the fact that at this point, we didn't realize just how risky it was, even converting code that looked like it was kind of like correct nullability-wise. And so what we now know very well is that when you have a non-null parameter in Kotlin, you're basically inserting like a check not null right there at the boundary. And so this caused searches in Marketplace to crash. So if you were searching for something in Marketplace in July of 2022, my apologies. Then...
Damn nullability.
Then there was a task created, but I didn't see it. And then we hadn't really set up escalation properly. So even though it was detected, by the time I came back, it was a SEV, basically. That's the third bit of our conversion ecosystem that I was talking about is born out of cases like this, where we realized that actually it was not that hard to detect these kinds of crashes because they all have a very similar feel and signature, and we know what we're looking for. We just have to look for it and then deal with it accordingly. Actually, and of course, it's always a little bit embarrassing when like the fix turns out to be like 2 characters. If you could Yeah, so you see that, yeah, those 2 question marks could have saved me a lot of headache. So now...
It wouldn't have saved you from COVID, though. Sorry.
That's true. Yeah, I would recommend also not getting COVID.
Cool. Anything else on that? Sorry, I'm interrupting.
No, I think I broke enough things.
Okay. Yep, you have. Okay, there are some other examples of broken things. Okay, and then, let's see, we are on to Ty. So what are the things that are hard at Uber?
I mean, definitely nullability, so I'll +1 Eve's comment there. I would say for us, since we're a little not as far along on the automated migration path, we're still dealing with a lot of human-related issues. Humans generating this and us still building post-processing steps gives them the need to, or at least they feel the need to make it more idiomatic or correct or fix things. So there's always the possibility of human error when you have developers doing a migration themselves, even with assisted tooling. So I would say that is one challenge. Another, also related to the people, is the organizational cost. Some people are very passionate and they want to migrate their code, and the tooling is very helpful for them. Other folks, maybe they have more important things to do, like shipping features for the business and providing shareholder value. So it's hard to convince them to do that sort of work. So those are a couple of the more people side that we're dealing with.
And how have you justified the investment that's been made into this?
That's a great question. I think a lot of the wins that I called out at the beginning, when I pulled out those numbers, a lot of those have been very widely distributed across our leadership, and there is a definite buy-in that this is important, that there's real business value, that there's real developer productivity that comes from this, and there's a lot of investments or technologies that are only possible in Kotlin, things like coroutines, which we're moving very heavily towards, or compose. So there is a need for these developers to get their code into it. So they feel kind of pulled by the platform. Also, they're often passionate, and they have a justification with some of our metrics to make room for that with their management as well.
And when you started this journey, you didn't have the data to back this up, and so there was some assumption that this would pay off. And it sounds like management now agrees that it is paying off. But yeah, great that they took the risk to do it anyways. Okay, and then on to Kevin. So Kevin, tell us about some of the things that are hard that are with verification testing, how Google deals with that.
Yeah, I think for us, because for all the use cases that I've mentioned, doing this sort of correctly is really paramount for us, because we're trying to do this at scale. And that's in particular been important for this journey with Kotlin native. Where we really want the translated code to behave exactly like before. But the great thing is we have a lot of tests, and so we're able to kind of leverage the test suites to give us feedback on that. Right? When people do manual conversions, which it turns out they do sort of self-driven, we recommend that they basically convert the test separate from the production code, and in fact, it probably makes more sense to do production first, because that way you're not changing the test, and to kind of give you some assurance, right? Like, test coverage isn't perfect, of course, but we do have a pretty strong culture of writing tests for things, and we're really benefiting from that. And in the automated conversion, I think we're benefiting from that even more, right? Like, you're converting all this code automatically, and then run all the tests for it and get some assurance that you actually did it correctly.
Nice. Great. Okay, anything else that's hard that we missed? Those are all the hard things. Yeah, sounds easy.
That's it.
You guys got this. Okay, so let's see. Okay, we already went through that. Skip. There we go. Okay, so we want to take a little bit to talk about where this is going. So this work group has been working on this, trying to figure out ways to work together, and we'll talk about that in a minute. But one of the things I did want to point out is we just created this new channel in the Kotlin Link Slack, which is J2K. And if you do want to be part of any announcements that we make or things to get involved in, opportunities to collaborate, that channel on Kotlin would be the place to do that. With that, let's start with Anton to tell us about where JetBrains is going with migration tooling.
Yes, JetBrains plans. Here are actually 2 tracks. that will converge. First one is a K2 compiler. We need to rewrite J2K for using new compiler, and we've done a lot of work with help of Meta. And in closed release IntelliJ 24.2, K2 mod will get J2K converter. Previously it didn't have it, now it will have it. It will have early version of converter. As I was saying previously, it will create workable code, but sometimes you need to do some polishing to make it more idiomatic. And we will work on code style things until next release 24.3. So in 24.3, K2 mod will have finalized the J2K converter. This is the first track, and the second track is we got some requests from our colleagues from Meta, from Uber, about improving API of J2K, making it more flexible to satisfy needs of these infrastructures, and we will also extend J2K converter API. That's about J2K, but I also want to share another direction, is AI assistance. Yes, maybe for such massive conversions, AI assistance cannot work well because it do not give guarantees. It works slower in case of code conversion. But in other segments of use cases, when you, for instance, have just several classes, several Java classes that heavily rely on some framework with a lot of annotations, compiler plugin, some complex logic hidden under the hood, and sometimes J2K cannot understand everything there. But I was really surprised how language models do this job. It really seems like they understand everything and they produce good Kotlin code. So we will invest in this direction as well to make AI solutions for these use cases production ready. Yep.
Awesome. So when the deterministic machine can't do the conversion, then you can go to the non-deterministic machine to do it for you. Yeah, great. And all better than having a human do it. So, awesome. Okay, so let's go on to Eve to talk about where we're going with pipelines.
So we have, at least at Meta, about 200-ish pre-processing and post-processing steps combined, and we need more. And I imagine that a lot of our use cases are similar. So kind of the hope that we've concluded over talking over several months now is that we can start to combine our efforts a little bit, and kind of there are like two formats that these steps could take. One is like what Anton was saying, where like a hook will allow us to add additional steps to run immediately after J2K and be able to leverage the power of IntelliJ, which involves simple resolution even on code that's broken, which is generally the state that it's in right after you convert it. For something like renaming, we want to get rid of all of our mfoos and make them foos. That's something we're doing right now on our own, but it's hard, and we may as well use the great tools that are out there rather than reinventing the wheel. So that's one area where we're hoping to collaborate and share steps.
Real quick, what's an mfoo?
Oh, you mean like Hungarian
okay.
notation? Yeah.
Got
it. And the other one is something which I think we're already kind of sharing some of these steps with Uber. We actually open sourced a handful of them, maybe back in 2022, I think, when Omer wrote this blog post, where it's just like a KT file, and we parse the AST, make some modifications, and with pretty minimal type information. We have some of our own internally, but it's a little fishy. But a lot of them you can do a lot of very useful things, even with just the bare AST. And it's like a numbers game. The more of these you churn out, the more conversions you can automate, the fewer humans involved, the fewer bugs, the fewer sub-reviews you have to go to. So,
awesome. Good.
divide and conquer.
All right. That all sounds good. So that's something that on that Slack channel, if people want to get involved with any of that, that's where we'll be communicating. Okay, now for Ty, I heard that AI is just going to make it so we don't have to do any work and it's going to do it all for us. And so can't AI just solve this?
Early retirement for all of us, right?
That's right.
Thanks,
That's what
AI.
I'm hoping.
I think for our future investments, I would really divide it up into 3 tracks. And one definitely is AI, but I'll leave that one for last and go through the other couple ones first. One is, this collaborative effort with the group here and the work with Meta. We do plan to upstream as we get the GitHub repo and the contribution model in place. We'll be upstreaming our steps that make sense and continuing to build out and work with the community for those. The other track is, we are also looking to move to a headless pipeline mode for generating diffs and having those reviewed by engineers and pursue a little bit of the more mature infrastructure that Meta has in place. So we'll be working on that this half. Lastly, though, we are pretty excited about AI solutions. We recently formed a new AI DevX team that we're working on a lot of cool stuff. Part of that is code generation. So we've been working with a lot of other peers in the industry, and we have some ideas for how LLMs could fit into this solution in a safe way. There's obviously a lot of risk because you want something that has a lot of verification. So we're going to have to be very careful to make sure we get correctness out of this. And they're still exploratory at the moment, but there's a few ideas. One from using the AI to generate the converters themselves, and then those are human reviewed, and then those are deterministic. We're doing similar with auto fixes for lints and other parts of some of our repos. Or in a North Star environment where we can get reliable signal from the LLM, there are techniques to make much more acceptable code, including multi-framework agents where you're giving the LLM access to tools like compilers and they go into an iteration loop, taking the feedback from that. Or mixing those with a set of deterministic and non-deterministic solutions. Both of those have proven numbers in going much higher in the acceptance rate. So we're thinking that in a long-term world where we can get that acceptance rate very high and verification very high, that may play a key part of our headless pipeline, and we'll be exploring that more in depth during the second half of this year.
Awesome. Then Kevin, you'd mentioned the standalone tools for doing migration. Anything to add to that?
Not a lot. I mean, I think we just want to help teams use them safely, right? Similar to what you guys are already running into, and so it's been helpful for us to kind of see how this plays out when you're a little bit further along. But teams do come out of the woodwork wanting to convert. And sort of typically after they've used Kotlin for a little while, they want to remove some of the Java code that they don't want to touch anymore. And so we're just looking to kind of put in place pipelines similar to what Uber and Meta have to do that safely.
Awesome. Cool. Well, we have some time for questions. So there will be a mic floating around. Raise your hand if you have any questions for these amazing panelists.
I think we need to hand one of our mics to the audience.
Okay. We've got a question. Where is it? Okay. There we got somebody in the back already with a question.
Run up to the front, grab a mic.
Yeah, go ahead.
Yeah. Thanks for the valuable insights. My question would be, you probably work with the biggest code bases out in the world. What would you recommend to small to medium-sized companies? Would you recommend slowly migrating, let's say, from Java to Kotlin and building the tooling necessary to support both? Or would you maybe recommend just, hold the breath and just do the migration as fast as possible? Thank you.
I can start this, and I'm going to give the most unsatisfactory answer and say it depends. I think it really depends on the size and the business motivations that your company has. If there is the expertise and there's the drive to get that done safely and quickly and centrally, then and you're done with it, and you don't need to kind of continue supporting a very complex infrastructure and dual set of languages, then that would probably be a conversation to have with your leadership and the Eng team that wants to focus on that. If that's not really scalable, even for the small to medium-sized company, depending on the lines of code, then it again depends on the business motivations for doing that work. The sort of investment that we're talking about is very large, right? You need dedicated teams for this, dedicated DevX people for this. Often small to medium companies haven't even formed those teams, or if they have a lot of responsibilities, and this becomes, it competes for priorities. So, that's where my "it depends" answer comes from. Anyone else?
Yeah, I would say get your nullability ducks in order first. Granted, we thought we were more done with it than we were, and I mean the conversion wouldn't be possible at all without the nullability work that has already been done. But in the course of converting, we've kind of backed ourselves into certain corners that if we had known then what we know now, we wouldn't have. One example would be you could have different implementers of a single interface that all have different nullability for a given parameter. Say you convert the interface, you've kind of locked in the nullability there. Now when you go and try and convert an implementer, if it doesn't agree with the interface you've already converted, it's going to fail to build. And that is, we were kind of very blasé about this initially. We were like, it'll be fine, we'll make everything nullable. But actually that was a terrible idea. And we've made our lives harder in the long run.
And you do a lot of analysis into the code base to try to figure out what the nullability actually is.
Yeah.
So it's hard and it takes work. But yeah, get your nullability ducks in a row. That's where you start. I like that. Okay, another question?
It's okay.
Good running.
Yeah, thank you very much for your presentation and interesting insights. My name is Maria. I would like to ask maybe a strange question. Before JetBrains will support fully conversion from Java to Kotlin in IDE, the tools that you used internally or tools that you created in Google, Meta, Uber, are they open to be able to reuse in another projects or are they used only by your companies?
Yeah, maybe Eve, give your recap of how you use the headless IntelliJ.
Yeah, so you're talking still about Java to Kotlin. You're not talking about like converting from like Rust, right?
No.
Okay, Java
Yes.
to Kotlin. Okay,
Yeah.
good, because I can't do the other one. Some of it is open sourced already. I mean, and we'd like to open source more of it. The headless bit, not so much. I kind of haphazardly open source that and it doesn't really work because it's gone out of sync. I mean, ours internally works, the one I open source doesn't. But we are, hoping that other people will contribute as well.
Great. Yeah, and then Kevin, about J2KT.
Yeah, I think, in general, like one reason why we're here is sort of to kind of invite more community participation and also help, to be honest. But yeah, we certainly are also looking at for other people to use the tooling. Some of it has been open sourced. I think hopefully we'll have more of it open sourced. There's certainly the hope that with more diverse usage, we'll also get kind of bug reports and hopefully bug fixes into those tools. Because at the end of the day, I think this conversion stuff, a lot of it is pretty tedious and detail oriented. But once you sort of fix an issue, you fixed it for everyone. And so I think sort of as a community, we can come a long way with that.
We just need one person to write the RX to coroutines and validate that it's not going to break anything. We just need one person to do that, and then...
Yes, we're still looking for that person.
Yeah.
So definitely
Volunteers?
get on the Slack
Volunteers?
channel if you are that person.
Yeah.
Hi, my name is Jan. I was wondering how satisfied you are with the output of your automated conversion, because what you would write in Java makes totally sense, like writing some builders, but in Kotlin you might, I don't know, use a scope function, for instance, so that lots of code would actually be dropped.
the idiomaticness of the outputted code. How do you feel about that?
Maybe I could start and then Eve could add to it. So we view it as kind of the goalpost is always moving. We're writing new post-processing steps as we find patterns. So there's always a feedback loop, and that's part of still having the developer-assisted tooling. It gives us a bit of that feedback loop.
And real quick, you can apply those post-processing steps on code as your patterns and the post-processing gets better to continue to improve the code base, right? This isn't just a one-time migration thing. Exactly.
But the other part of that is having a perspective that the code is perfect is probably a flawed start. If you're trying to say, I want one commit that gives me the perfect idiomatic Kotlin output, that's not really the goal we're taking. It should be maintainable, it should be decent, it should follow best practices, and it should be correct. And if the developers then want to further optimize, we want to do that decoupled from the migration so that we first have a level of correctness and a baseline, and then they can go in and, depending on their own preferences for maintainability or their own, how nice they want that looking or swapping APIs out, they can do that after.
Yeah, I would just add that we want it to be idiomatic, and I would say maybe at least a quarter of the time. It's hard to give an exact number for a variety of reasons. Like, we look at the output and we're like, great, ship it. It's beautiful. Sometimes we're like, I could live with that for now, and I'll code mod all of that later, since we have these post-processing steps, which are very easy to apply to thousands of files at once. So often that's the most efficient way to do it. But we really are trying to hit kind of a happy medium where the code is not so idiomatic or not taking advantage of all the fun new features such that it becomes hard for developers to review, especially bearing in mind a lot of people are learning Kotlin as they're converting it. But we also don't want to leave the temptation there for people to get clever. In particular, nullable booleans are a big foot gun where people would try and get clever and use the Elvis operator to condense things, and they would get it slightly wrong. And so we started trying to automate that for people, even though it wasn't necessary for the code to compile, because we didn't want that temptation to be present.
Nice. Great. Well, with that, it's time for the party. So hopefully that was useful to you all. Get your nullability ducks in a row. That's where you start. And we'll see you at the party. Thank you. Thanks, panelists.